Hello students, welcome to the next lecture on the CSIR NET July 2025 solution. Today I will explain you the question ID 562954107, question related to the quadratic form. Myself Dr. Harish Garg. You can follow and subscribe my YouTube channel where you can see I had uploaded the complex analysis, differential equation part B and part C, partial differential equation, integral equations and many more lectures related to the complete solution of the CSIR NET July 2025. You can follow and subscribe my this YouTube channel so that you can get the notification when I upload the next video. Now look at that, this question is related to the quadratic form, and again you can get the answer in the 15-second time period. Fine. It's a very simple way how you can get the answer. First of all, if you look about the option, he said positive definite matrix and so on. What is the positive definite matrix? That means if any of the function kux is greater than 0 for all x, it's my non-zero. Fine. अगर ये property satisfied होती है, then we call as the positive definite quadratic form. Fine. Now you can read the statement carefully. They said V is the vector, V is the collection of all those cubic polynomial of the form ax cube bx square plus cx such that a, B, C is R. Fine. Now, as I mentioned you, quadratic form is Q of x is greater than 0 for all x which is my non-zero. So in this case, x is my f. So basically, your target is to prove Q of f is greater than 0 for all f which is non-zero. तो सबसे पहले ये non-zero कब बनेगा? When A, B and C all are my non-zero. फाइन. कोई दो जीरो हो सकते हैं, इट मे बी पॉसिबल टू आर जीरो बट थर्ड वन इज नॉन जीरो. क्लियर? तो यही इस क्वेश्चन का पूरा बेस है. क्लियर? चलिए, सबसे आसान कैसे होगा ये? आसान होने के लिए मैं ए को जीरो ले लेता हूं, बी को जीरो ले लेता हूं, सी कैन हैव एनी वैल्यू. तो आपका एफ क्या बन गया? एफ इज द पार्ट ऑफ द वी. फाइन. सो इट विल बी माई सी एक्स. फाइन. देन योर क्वाड्रेटिक फंक्शन -1 to 1. What is the f dash? F dash is my c square. यही होगा. So the integration becomes 2c square. And definitely this number is always greater than 0 for every value of the f. Fine. Because c, whatever the value of the c, because of this square, it is always greater than 0 for all c which is my non-zero. अगर c 0 हो गया तो f भी आपका 0 हो जाएगा. इसका मतलब f is my quadratic form, but we need a false statement, so that is my correct statement. तो ये ऑप्शन कैंसिल हो गया. सेकेंड वे आप इस तरह से भी देख सकते हो, बिकॉज f डैश स्क्वायर इज ऑलवेज ग्रेटर देन 0, बिकॉज f आपका कभी 0 नहीं हो सकता. फाइन. f डैश स्क्वायर इज ऑलवेज ग्रेटर देन 0, देन also you can say this is the even function always. Fine. Then integration from -1 to +1, integration from -1 to +1 I can written as 0 to twice of the 0 to 1. This number is always positive. Integration from the 0 to 1 is always positive. Fine. The first option is the correct option. Correct option, but we need a false statement. Second is takes every positive real number. Yes, for the different value of the c, if you choose the c is 1, then answer will be 2. If you take c is equal to 0.1, then the answer will be 0.02. So yes, all take the positive real number. Is it possible that Q of x is my 2? If the second option is the correct statement, because it's take every positive real number, it is also the positive real number. So C option is also the correct. Moreover, you can also say what is the value if you take c is equal to 1. Fine. Then clearly say Q of x is my 2. So the only option which is left behind is this is my false statement. And how you can prove that? Again, it's a very simple. I can see, I can choose f is my x and g is equal to my 2x. Then what is my Q of f? Q of f is my twice of c square. C is my 1. What is the Q of g? Is a twice of c square. So 2 into 2 square, 8. What is the Q of f plus g? What is the value of the f plus g? Is my 3x. So 2 of c square, 9 to 18. Clearly say the sum is my 10, which is not equal to 18. So the right answer is D is my correct answer of the problem. So you can see that it's a very simple question. You just take the all those value as per your convenience. For more details, as you all knows, I already uploaded the quadratic form. If you watch my quadratic form lecture,